So inverse properties, we're going to start talking about the inverse of functions and relations and how to calculate that and how to find that. So if we have a point xy that is on the function f of x, so if I were to graph any function, we would find an ordered pair x and y. If I were to find the inverse of that function, then y of x would be on the graph of the inverse. So what this means right here is my inverse function. I would call this an inverse. So the graph f of x and the inverse of f of x so its inverse are reflected across y equals x. So if I were to actually graph y equals x, I have graph right here. Y equals x is just a diagonal line, goes through the origin, a positive 1 slope, up 1 over 1. So if I have a function, its inverse is just reflected across this line right here. So if I had a dot here, the inverse would be directly reflection across that line. So let's say that I had a point 3, 4. So 3, 4 is located on my function f of x. If I were to figure out what its inverse was, then I would just switch my x and y. And so the ordered pair 4, 3 would be on the inverse. So to find the inverse of an ordered pair, all I do is just switch x and y. So the next example, if -3, 2 is on the graph f of x, then what point is on its inverse? So all I would do is switch my x and y. So the point 2, -3 would be on the inverse. Just switch my x and y. So it's really easy with ordered pairs because all you're doing is switching the point. If I have a function, so the first example, let's say that it is y equals 3x minus 5. The process is a little bit lengthier. So the first step is to write the equation. If it's in a function notation, I just want to write y equals here. And so we'll get to an example like that in a minute. Once you have it in this form, I'm going to switch my x and y and rewrite it. So when I switch my x and y, I now rewrite the equation as x equals 3y minus 5. So the only thing that I did is I took my x and my y and I switched them. And I rewrote it. So once you have that, you are going to solve for y. So once you have switched them, that's your step 1. The second step is now solving for y. And so it's just a linear equation. So to get y by itself, I add 5 to each side. So I would write this as x plus 5 equals 3y. Then I divide everything by 3, and that will cancel. So I will rewrite this as y equals, I'm going to distribute this 3 underneath the x. So 1x over 3, or 1/3 x. Then I'm going to distribute the 3 under the 5. So plus 5 over 3. And then the final step is to write this as an inverse. So I'm going to replace my y back again. My final answer would be f to the -1 of x, which just means that this is an inverse function, equals x over 3 plus 5 over 3. Okay, the next example is y equals negative 4 x plus 2. So first step is I'm going to switch my x and y and rewrite it. So when I switch my x and y, it becomes x equals negative 4y plus 2. This is a y. Then I want to solve for y. So in order to get y by itself, I need to subtract 2 from each side. So I would rewrite this as x minus 2 equals negative 4y. And then divide each side by negative 4. So y equals, I'm going to put the negative 4 under the x. So negative 1/4 x. I'm going to put the negative 4 under the negative 2. So it would become a positive since you have a negative over a negative. And 2 over 4 would reduce to 1/2. And then final step is to switch my y back to inverse function. So f to the negative 1 of x, or inverse of f of x, equals negative 1/4 x plus 1/2. And that would be my final answer. The next one, we have y equals, or I guess it says f of x equals 2/3 x minus 5. So when you have an f of x, all you do is you switch that from f of x to y equals 2/3 x. Because remember, f of x and y are the same thing. This just is read as the function of x, and then this is just read as y equals. So sometimes you have to switch f of x to y first before you can switch x and y. So once I have this written, I'm going to switch my x and y, and I will now write this as x equals 2/3 y minus 5. And I solve for y, so add 5 to each side. So x plus 5 equals 2/3 y. In order to get rid of my 2/3, I need to multiply by each side by the reciprocal. So in order to cancel out this 2/3, I need to multiply by 3/2. Whatever I do to the left, I also have to do to the right. So 2/3 and 3/2 will go away. It will cancel out. So I will rewrite this as y equals, I need to distribute my 3/2. So 3/2 x plus 3/2 times 5 is the same thing as saying this imaginary 5 over 1. I multiply across. 3 times 5 gives me 15. 2 times 1 gives me 2. And then the final step is to switch back the y to the inverse function. So my final answer would be the inverse of f of x equals 3/2 x plus 15 over 2. Okay, the next example, it says find the inverse of y equals x squared. So since it's already in y equals form, I can just switch my x and y and now write this as x equals y squared. In order to get rid of this squared, I'm going to square root each side. And so that will cancel. And I get y equals the square root of x. And final step is to switch out this y into inverse. F of x is the square root of x. So that would be my final answer. So then the next one, I'm going to erase this. This next one, it wants us to graph. And so it wants us to graph y equals x squared. The domain is restricted. We only care about x is greater than 0. We don't care about less than or equal to 0. So we're going to draw the entire graph, and then I can erase the part where x is less than 0. So I'm going to draw my graph. Like this. Beautiful. And I want to graph x and y. So here's my x, here's my y. So let's plot the points 0, 1, 2, and 3. And this is for y equals x squared. So if x equals 0, and I'm plugging it in here, then y would be 0. So I'm going to put a point at 0, 0. If x equals 1, 1 squared is 1, so I'm going to put a point at 1, 1. If x equals 2, then 2 squared is 4, so I'm going to put a point at 2, 4. And when x equals 3, 3 squared is 9, so I'm going to put a point at 3, 9, which would be up here at 3, 9. Then I connect the dots, and I can also reflect across the x-axis. Be here. Then if I wanted to find the inverse, which we already did in the last example, we said that the inverse is the square root of x. So if I were to plot points for that, using the same x values, the square root of 0 is 0. If I were to just find the inverse, instead of having to plug into this function, I can just switch my x and y values. So that might be a little bit easier. If I switch my x and y values, then my new ordered pairs would still be 0, 0. I would still have 1, 1. The 2, 4 will now switch to 4, 2. And the 3, 9 will now switch to 9, 3. So if I want to graph this, I still have 0, 0. I still have 1, 1. But now I'm going to go plot the point 4, 2. And 9, 3. So my inverse function will look something like this, which makes sense because remember in the very beginning when we talked about inverses being reflected across y equals x. This is my line y equals x. Aren't these direct reflections across that? Like if you were to fold this in half, both of these lines would fit or would mirror y equals x. So all we had to do is just switch the x and y values. The next example, we have y equals x to the 6th power. And so if I wanted to find the inverse of that, I would still just switch my x and y values. I would write this as x equals y to the 6th power. It's kind of the same process whenever you are getting rid of a square root or getting rid of a squared, you square root it. Same with this 6th power. You would take this 6th root. And so you don't actually have to solve that algebraically. I'm not going to make you solve anything. You just have to know that the opposite of something to the 6th power, it would be the 6th root. So I would rewrite this as y equals the 6th root of x. And I'm going to change this y now to inverse of x equals the 6th root of x. And that would be my final answer. Last example, it says find the inverse of g of x equals 1/27 x cubed. So the first thing I need to do is I need to switch this to be a y equals. So I'm going to rewrite it as y equals 1/27 x cubed. Next step is I'm going to switch my x and y. So I'm going to write this as x equals 1/27 y cubed. Now I want to get y by itself, so I want to isolate my y. In order to get rid of the 1/27, I can multiply each side by its reciprocal, which would be 27. And so when I do that, my 27s will cancel. And I can say that 27x equals y cubed. Then to get rid of the cubed, I need to cube root it. Cube root each side. And so when I cube root 27x, I'm just going to write this over here. I need to see if I can simplify this, kind of like we simplified our square roots. If you typed this into the calculator, so I'm going to separate this. The cube root of 27 is actually just 3, because 3 times 3 times 3 would be 27. So 3 to the third power would be 3. So I can simplify this. Cube root of 27 is 3. Cube root of x. And I need my final step is to switch my y back to inverse. So f to the -1 of x equals 3 cube root of x. That would be one of the more difficult problems that you see. Then finally, if the question says, is the inverse a function? You have this thing called a horizontal line test. So a horizontal line test is used if the inverse is a function. If passed. The vertical line test, you can recall from, I think, the second unit. The vertical line test proves that the relation is a function. So this is just for the actual f of x. This is horizontal line test is for the inverse. So for instance,